Students, welcome you all for the 7th class of Laws of Motion. What did we study in the last class? We have discussed what you mean by Newton's last law. That is Newton's third law of motion, and we understood that for every action there is an equal and opposite reaction, and action and reaction doesn't happen on the same object. This is a very important keyword you need to keep in mind when you study about Newton's third law of motion. So what is the importance of Newton's third law of motion? We study about the nature and its understand. So in today's class we are going to study about the last topic of gravitation. This gravitation topic itself we need to do in 2 classes. In a single day it is not possible, it is quite large, and lot of the concepts we need to understand very well. So first about the gravitation, we have what we mean by universal law of gravitation. What is universal law of gravitation? No doubt this law is also given by what you mean by who is known as Newton. Sir Isaac Newton only formulated the universal law of gravitation. So what actually the universal law of gravitation tells us? So let us understand word by word. So what did Newton tell is every particle in the universe, every particle in the universe attracts every particle in the universe attracts every other particle. Every particle in the universe attracts every other particle. See, this is the word we need to understand very well. Every particle in the universe has a capacity to attract one more particle because of the mass. Because all the objects are made up of what? Mass. So every particle in the universe attracts every other particle. Let me show you. Consider 2 bodies. Consider this body is M1 and this body is M2. Right. So according to the Newton, every particle in the universe, for example, consider this is universe and I am having 2 particles. Every particle in the universe what attracts each other. It attracts other particles. Think the force here is the force of attraction by M1 on M2 is Fa, and the force of attraction on this Fa. It is applying a force of Fa on this object. It is also in turn applying a force of Fb, and both are having a distance of r. Think that the distance between them to be r. Understand? So according to this universal law of gravitation, every particle in the universe attracts every other particle. Every other particle, look at here. With the force, first one, with the force that is directly proportional, to the product of their masses. What is it? Look at it. Among that, whatever the force which is being attracting each other is directly proportional to the product of their masses. Mathematically you can write force directly proportional to product of their masses. It is having mass M1, this is having mass M2. Consider this to be equation 1. Understand, this is according to Newton's law of gravitation. Then, with the force that is inversely proportional to the square of the distance between them. To the square of the distance between them. This you can write as mathematically. Yep. What is the distance I have taken here? R, but that is inversely proportional to the square of the distance. So inverse means 1 by r square. Why I have taken square? The reason is it is square of the distance. proportional to the product of their masses and that is inversely proportional to the square of the distance between them. When you want to write a definition, look at it. You need to write first this. Every particle in the universe attracts every other particle. Then directly come here with the force that is directly proportional to the product of their masses and that is inversely proportional to the square of the distance between them. Understand it. See, mathematical way of this I can write as F directly proportional to M1 M2. Second one, F inversely proportional to 1 by R square. So by combining the equation, combining equation 1 and 2. When you combine equation 1 and 2, what I have? Equation 1 is directly proportional to M1 M2. Okay. This is equation 1. Again I am writing. Okay. But combining equation 1 and 2 you can write directly after that. But to make you to understand I am writing. Next I have F inversely proportional to 1 by R square. So when you combine both, towards LHS I have F, no doubt. Towards LHS I have F directly proportional to M1 M2 by R square. Understood? Like this we have done many things. Understood? Now I have, this is the expression. You see here you have proportionality. Always I need to remove proportionality and put equality. When I make it to equality, what happens? So F is equals to G M1 M2 by R square. Here what is G? G is gravitational constant. For example, in the case of F directly proportional to M, F directly proportional to A. Therefore, F directly proportional to MA. Here what did I write? Constant of proportionality. F is equals to KMA. Here K is constant of proportionality. When you are doing Newton's second law of motion. For example, you have learned what do you mean by Ohm's law. What according to Ohm's law? According to Ohm's law, the potential difference applied across the conductors is directly proportional to what? V is current passing through it. V directly proportional to I. V is the potential difference. I is the current. The potential difference applied across the ends of the conductor is directly proportional to the flow of current, provided that temperature remains constant. That thing you have to do. So when you remove here proportionality, what happens? IR. Here R is what? Constant of proportionality. Like that, the same way we have here. So we are taking here, since we are studying of what you mean by gravitation, when we remove this proportionality sign, I am taking G as a proportionality constant. Understand? So G is proportionality. G is the proportionality constant. Or we can call it as gravitational constant. What it is known as gravitational constant. Understand? Very much easy. Now to make you to understand still what you mean by Newton's universal law of gravitation, when they ask, first you have to write this thing compulsorily. That is, every particle in the universe attracts every other particle. Why? Because of masses. Because of masses. Because both having the masses, right? That masses makes to attract each other. Then according to Newton's what? So with what? They are attracting with the force. They are attracting with the force. Which force? How? That is, force is directly proportional to the masses. Whatever the masses they are having, force is directly proportional to the masses. Next one, force is inversely proportional to what? Square of the distance. Square of the distance. Means, with increasing masses, force also increases. That is the meaning of directly proportional. What do you mean by inversely proportional? With increasing the distance, force become what? Less. Force become less. Understand? For example, you are lying on the earth. Now the gravitational force on you is less. But when you go up, when you fall from the floor, what happens? The gravitational force is more. The reason is, what is the distance is more. When the distance square of the distance between them is less, the force is more. Example, understand? See, you might have played this. You go to second floor, ask your brother or someone to throw the keychain. When it is being coming in the nearby to first floor, you feel it is coming very slow. But once when it reaching near you, you feel that it is coming with very force. So lesser the distance, greater the force. Understand? This is about what we mean by universal law of gravitation. These mathematical expressions are very important. See, understand, removing proportionality, I have taken equality. When I take equality, I need to take constant of proportionality, that is G. So G is known as proportionality constant or gravitational constant. So now let us see what is the unit for G. Example, see here. Let me do here only. Unit. What are the unit of G? That is gravitation. So change the expression. If you want for expression of G, what happens? This R square goes up. That is F into R square by M1 into M2. You must learn by this way how to change the expressions. Now, what is the unit of force? Force unit is Newton. R square is distance. Distance means it is meter square. M1 into mass. What is the mass SI unit? kg. Here we have two masses. That is kg into kg. So we get what we mean by this. We have Newton meter square per kg square, or even we can write as Newton meter square kg minus 2. Understand? This is the unit of what we mean by. See, once when you know the formula, easily we can recover what are the units of that. And also we have value for the G. We have a value that is G is equals to, this value is very important. Understand? Well, it is important when you go to your higher classes, they will ask you. But in this, our examination, what probably they want. But remember, this is very important. That is 6.67 into 10 to the power minus 11. You need to remember there is a lot of difference between minus and plus. When you write plus, it's not at all equal to this. Understand? Now, what is the unit of gravitation? Unit of gravitation, you know it is Newton meter square kg minus 2. This value of G is very important. I hope you have understood what you mean by universal law of gravitation completely. Now we will see that what are the importance of gravitational force. What is the importance of gravitational force between two masses, and what is the importance of law of gravitation also. Next we will further go for what you mean by free fall and all that we will see. Now we will see some of the important force between gravitational force between two masses. What are the things it is happening? What is the gravitational force when you consider between the two masses? First one is always attractive. Obviously, you know, according to Newton's universal law of gravitation, what did he found? He told that every particle in the universe attracts every other particle. So, the gravitational force between these two objects, is always what? Attractive. It's not repulsive. Understand? Gravitational force between these two masses is always attractive. It is getting attractive. That is what the first point. That is the first point. It is always attractive. It means what? Gravitational force is always attractive between two masses. Is directly proportional to the masses. Gravitational force is what? Force. See, already we have drawn this expression. Right? Force is equals to G M1 M2 by R square. In this expression, what is this F? F is force. What force? Here it is gravitational force. Understand? So gravitational force is directly proportional to what? Masses. We have seen force is always directly proportional to what? Masses. This is our second point. I hope you understood this both. Remember always, gravitational force between the masses is always attractive. First one. Second one is directly proportional to what? Masses. Third one is inversely proportional to the square of the distance between them. We have read. See, is inversely proportional to the square. If the distance moves, if the distance is keep on increasing, force becomes less. If the distance is keep on less, if the distance is less, force is more. Understand? That is what we tell. Force is inversely proportional to the square of the distance between them. Inversely is always it is. If distance is less, force is more. Opposite. If distance is more, force is less. Understand? So this is what we need to understand in this concept. So look at this. They will give for very important application question. By doubling the separation of masses, what will be the force of attraction? They will give you that. They are telling that if you by doubling the separation of the masses, if you double the distance between the two masses, what will be the force of attraction? Obviously, force becomes more or less when you separate the distance more. When you double the distance, see, before you have, this is the distance. The distance of, for example, let us consider 2 meters. If you double it, this goes beside 2 meters, 2 meters. Then what will be the force? Force is less or more. If this distance is more, force is obviously less. So, force of attraction reduces to 1/4. Very, very important application question. Remember this is. Understand? I hope you have understood this. Gravitational force between the masses. Right? It is always attractive. It is directly proportional to the masses. Inversely proportional to the square of the distance between them. So, when the distance doubles, always remember force of attraction reduces to 1/4. Now we have this. This is also very important 2-mark question. Very important 2 marks. Importance of law of gravitation. What is the importance of law of gravitation? What did Newton do after inventing it? See, if he had discovered something, some use should be there from that. Is it not? So what is the use? Importance of law of gravitation is Newton used this law to explain motion of planets around sun. By this law only he explained motion of the planet. Now, for example, sun. You know that all the planets are revolving around the sun, right? This revolving in a separate axis, but I am just for reference I am showing you a single circular path. So, what making them to move? That is gravitational force by sun. Sun is applying a gravitational force. Means if you think this is sun and this is earth, every particle in the universe what? Every particle in the universe attracts every other particle. Then only sun can attract moon. If that was not possible, see, Newton didn't discover something. After Newton discovered earth is not rotating. Earth is revolving from many years, billion, that's a creation of God. Right? But he explained what makes earth to revolve around the sun. That is what it is. Attraction of the masses between them. Understand? Then we also know that if planets are revolving around the sun, motion of the moon. Moon is revolving around the earth. Why? Moon is the only natural satellite of the earth. So motion of the moon. And there are not only many satellites are there. Many satellites which we have launched. That is all revolving around the earth. How it is revolving? Because every particle in the universe attracts every other particle. Then motion of the free fall body. Even the motion of a free fall body, look at it. This also was explained by Newton by using what we mean by universal law of gravitation. Understand? Now we will see next topic, that is force due to gravity, and wind up today's class. Now we have our next topic, what we mean by force due to gravity. So what is the force due to gravity which is happening? Let us see. According to the law of gravitation, what we study, the earth attracts each object around it. Right? Obviously, sun is being attracted by the earth is attracted by the sun, no doubt. So, upon the earth, can you see that earth has a capacity of attracting all the objects which is being around it. It just, what you mean by attracts towards its center. This concept of what you mean by center of gravity you will study in your 10th standard. Understand? But remember, earth has a capacity or the ability to attract all the objects around it to which the earth attracts the body, it is called force due to gravity. Very simple. See, obviously, you know what do you mean by force due to gravity means earth has a capacity. If you consider this as an earth has a capacity to attract any objects towards its what? Towards its center. If earth is attracting some object towards its center, earth should have some force, right? Earth should be applying some force upon the object. Simply can it attract? No. There is some force which is being acting by the earth upon that object to attract towards its center. Such force is known as what we mean by force due to gravity. We obviously know what is this force called? Gravitational force. What we call as gravitational force. There is a name also for the gravitational force. And you also know value for the gravitational force. Acceleration due to gravity. G is equals to 9.8 Newton. We have done that. And today also we are going to prove that how they will get 9.8 Newton. Why the value of G is 9.8. Understand? So what do you mean by force due to gravity? Earth is attracting every object towards its center by a force. And such a force is called as what you mean by force due to gravity. In other words, the force due to gravity is also called which force? Gravitational force. Understand? So now we have an expression for this force. This is the force expression. Remember, force due to gravity is G capital M small m by r square. Here, what is F? F is a gravitational force which is acting by the earth. What is the G? G is the gravitational constant. Whatever we have studied. What is the value of gravitational constant? 6.67 into 10 to the power minus 11 Newton meter square kg. And this capital M is mass of the earth. Mass of the earth is the standard value, that is 5.96 into 10 to the power 24 kg. See, if you make this minus, it's very less. If it is plus, very carefully you have to take 5.96 into 10 to the power 24 kg is the mass of the earth. When you consider earth means its mass is how much? Mass of an earth is 5.96 into 10 to the power 24 kg. Kg is a SI unit of mass. Next, what is this R? R is the radius. What is the radius of the earth? This radius of the earth is how much? 6.37 into 10 to the power 6 meters. This is the radius of the earth. Then what is the M? M here is mass of the body. That is, I have taken one object of 1 kg to find out how much force will earth put on the 1 kg of mass. Means the mass is some object which is here. There is 1 kg of mass of an object. What did we understand by force due to gravity? Earth will put some force on the object and attract towards its center. Now we will see when earth is being having force on this object, with what force it will attract that object towards the center. That is what my intention to prove you now. We have values. Let us apply for this. So F, we are finding this F. What is the value of G? 6.67 into 10 to the power minus 11 into what is capital M? Mass of that is 5.96 into 10 to the power of 24 into small m. What is one more small m I have taken? What is small m? Mass of that kept. That is 1 kg by r square. Radius is how much? 6.37 into 10 to the power of 6 whole square. This you will do when you go to your higher classes. But now let us write a direct value. No need of the calculation because we need a calculator to do that. Scientific calculator is needed. Now I will write the force. After solving this, I will get the answer as 9.8 Newton. I will get an answer as 9.8 Newton. Look at the standard value. Means, what did I understood here? For 1 kg of substance or 1 kg mass or 1 kg weight of an object, I should put 9.8 Newton on that to attract it towards the center. When you Understand? It depends. So now you can calculate for your own weights. Think that you are here. Earth has been attracted you towards the center. So only you are walking easily on the earth. Means Earth is having some force on you. How much is the force? You can find your mathematics. Understand? So this is what my concept of what you mean by universal law of gravitation and what you mean by force due to gravity. All the things whatever I have done is very important and please understand it. The entire chapter of laws of motion is very important. The basic physics is lies here. And even motion in one dimension, that is also a very good chapter. And measurement and experimentation, all are important chapters. These all are called as mechanics. Whatever I am dealing is of mechanics. Understand? So even current, electricity, magnetism, all the chapters which are there, please learn the basics very well. These are important for your future. Understand? So in the next class we will see some of the 3-4 objects. Still 1 or 2 more classes I will be still dealing with gravitation. Then we can going up this chapter. So prepare well for your unit test. If you have any doubt or doubts, be free enough to ask. Don't be blindly, you cannot attend the questions. Understand? So until next class, take care.